same. I felt like the screen was cut short. That's why I restarted the projector. It's gonna show the whole screen rather than only half of it, you know? But I should restart the projector. It's still like, only showing a small part of it.
I think it might be because it's all the way down, so if you were to put it up just a little bit, like the screen,
Yeah, I
like the
don't know
physical screen.
I don't know how to change the angle, you know?
Oh, that's,
Yeah, if we can move the whole window up a little. I'll just adjust the computer then. So this is the first question for today. We're reviewing for the final exam. There's already a study guide online. You can find out what kind of question we're expecting. There'll be, I think I was planning on for 10 questions. We have 10 questions for the final exam and kind of planning on 10 points per question. I opened up a new homework site, web work, so we get practice. That's right, thank you. If you're attending online, I have opened up the projector, okay, I got it, the scanner. So I'm starting to scan solution. I see one of the answers was wrong. You want to make sure that you double check your work. This is one of the homework from 6.1 is integration by part. What we're calling integration by part is integration of u dv equal to u times v minus integration of v du. And that's really the process. But here we have du dv. Those are representing a differential of a function. So we have to like actually identify the u, identify the v. Integration of u dv expecting us to, for the u, you have to be able to differentiate and find the du. With the dv, you have to integrate it to find the v. So it's an integration process and unique process. The integration by part is really an integration version of the differentiation by part. By differentiate the product over. So remember what practice we did for 6.1? I hope that being one of these the first section that we cover in calculus 2, we probably have some memory of how much work you've done and studied. So how is the sound if you're attending online? Right, let me know if you have your link. Looks like the sound is okay on my side. I can see the mic. Right, those of you that already submitted the answer. Let me turn off the scanner for a moment to see how many. Right, so far 7 was right. 1, 4 answer was wrong. So I can see this question are not a definite easy question. So let me try to explain the process so you kind of see how we get the right answer. I have the scanner on, so if you did more calculation, realize what would be the right answer, feel free to change your answer. With the online clicker page, you can always click on the A, B, C, the dot, or that to change your answer. So the calculation, let's follow what we did at the beginning of the semester. This is a multiplication. You consider part of the u, the other part is v. We follow the Layet process. L is logarithm. If you see a logarithm, that's u. I represent inverse trig. If you see an inverse trig, that has to be the u. Unless there's already a logarithm. So whatever is the first, this is how you choose your u. LIA. Now, if you don't have a logarithm, you don't have inverse trig, then IA represent algebraic, so which would be a polynomial. In this case, we do have one, which is the x, that's a polynomial with degree of 1. So in this example, we will set u equal to x. Right, and then the other one will be trig, and so if you don't have polynomial, you only have trigonometry, and then your trigonometry, like this, sine 6x will be the u. But now we already have the a, we have the logarithm, so we definitely have that. So this gives you an order, like how do you choose u based on this order? The last one will be e, if you do not have logarithm, do not have inverse trig, do not have algebraic function, do not have trig, and the exponential function will be the u. Okay, so that's really the process, like the order, how do you choose the u? Now, based on this, we're gonna choose u equal to x and the rest of the calculation, which is this. So we are considering this as integration of u v. Since u equal to that x, then all the other part are dv. So we would write dv, it's equal to the sine 6x dx, like the whole thing, right? This is indicating this is actually a differential. Being a differential, it is a derivative and the differential of the independent variable. So we know sine 6x is a derivative. If you already have the derivative, you want to find the antiderivative of the integration process. So the calculation for v will be v equal to the antiderivative sine 6x, you integrate it. Integration of sine 6x is negative cosine, so we have negative cosine 6x. Now we have to do a chain rule. If we don't do anything, the negative cosine's derivative is sine. Right? Derivative cosine is negative sine, so derivative negative cosine is sine. But then you have to multiply 6 if you differentiate it. But since we have that sign, we have to divide by 6 to avoid having an extra 6 in here. So if we don't have multiply 6 in there, we have to have a division by 6 here. That's the inverse chain rule. That's the v part, that's the integration part. But the u is the one you have to find the derivative of to find the du, which means you gotta find derivative of x, which is 1 time dx. Or you can just also think of it as just simply du equal to dx. That is the preparation for writing out the answer. We're just letting you know what was the u, what was the v. Now we set this whole thing up because we want to know how to apply the integration by part process. The process says, according to integration by part, this is equal to u times v minus integration of v. Right, this formula is the integration by part formula. So applying that formula with our function with the actual function, I mean, this is equal to, I mean, that is the integration u dv. So that equal to u times v, which is this u times this v. So we would have x multiplied, so it's negative x multiplied to cosine 6 over 6x. So we put 1 over 6 to the front, and we have cosine 6x. Okay, so that's the u times v. I mean, based on all these choices, I guess it's easier to just write x over 6. And then we wouldn't have to have that x just multiply. I'm trying to try to write a little bit better. I tend to, whenever we do that. That's u times v. We will turn this into minus the process of integration by part is writing the original integration into something slightly easier to integrate. This minus integration of v du. This is our v, so it's negative cosine 6x over 6. And then v du, the du is dx, du equal to dx. So that's the du, which is dx. So that's minus integration of v du. And now we see that part of the calculation is already done. This part is done. So we will finish this part of the integration. But before you do that, this is a negative, two negative cancel that become a positive. So this is negative x over 6 cosine 6x. Negative is positive, and we will integrate cosine. Integration of cosine is sine, so we have 1 over 6. And then that was this 6. You still have the 1 over 6, and then negative become positive. integration of cosine 6 is sine 6x. And again, the inside is a chain rule, you divide by 6. This is only integrating that part, you will have this. And then the denominator 6, you still have that 6. Okay, that's all the component part. And then let's see. So now we're gonna pretty much finish with the integration. Of course, it will multiply out the denominator, and that's the whole process of integration by part. And try to follow whatever we did at the beginning of semester, so we have kind of seen a review. So this is a slower process of doing integration by part. As you can see, in the textbook, we don't normally see the U, the dv, the udv. But once you are fluent with it, you don't have to always write out and want to put it in the block. But knowing those kind of makes the process a lot more clear. Right, I hope that you have all submitted your answer. Okay, so I see most of us has already submitted the answer. It should be B is negative x over 6 cosine 6x plus 1 over 36 sine 6x. We have 1 over 36 is because there's a denominator of 6. You gotta multiply them. So then these two multiply, that's where we get this 36 from. And that's why we see this answer as the right answer. So if you made the wrong choice, double check your calculation, see what was the difference in our steps. Okay. So this is for the attendance. So let me know if you have any questions. Alrighty, I hope that you already finished your chapter 6 homework or chapter 9, but I will mention a couple of things before we start today's class. I'm probably gonna try to review for the final exam. If you look at today's content, number 1, I want to remind you, if you haven't taken the post-test, please take it because we really wanted to see by the end of the semester how much, compared to the beginning of the semester, how much do we know. When you click on the post-test, it's under course tool inside quizzes. You're gonna find the post-test. I won't be able to take it, but I can possibly preview. Similar on your side, it's a 7 multiple choice question. The first one, it with a volume calculation from section 7.2 or 7.3. The second question is a improper integration, so we integrate from 1 to infinity, and that you might have done something like that in section 6.7, 6.6. This is an infinite sum. This is a geometric sequence. It's actually inverse interval convergence. So that would be chapter 8.6, which is power. This is a power theory, which is infinite summation of a power function. You want to find the radius of convergence and find the interval convergence. This is a question that will be an integration by part, similar to what we did today. But you want to remember the u is natural log, and then the dv is x cubed dx. And the last question is a trig integration. So that's 6.1, a trig integration with 6.2. So hopefully this is okay. Try it. Please take the quiz. Right, so that's my reminder. I just want to make sure more people participate. Another thing is the course evaluation. If you have already done, and I would say thank you because we really needed the feedback. And because teaching the course is one thing, and on the receiving side, overall, what you did or what I did the whole semester, I hope it's effective and I hope it's not. I hope I didn't make the calculus a painful process to learn. So hopefully I provided enough assistance that you actually enjoy learning calculus, or at least you're not afraid of learning calculus. Right, please fill out the course evaluation. So for today, the rest of the time we'll be trying to review for the final exam. At the beginning of the semester, I already posted a study guide for the final exam, and that basically reflected a plan, like what we trying to learn. And those are 10 questions that's really, really typical for anyone who has passed calculus 2. So calculus 2 focus heavily on integration, or how do you use integration to answer questions, solve problems. So the first 1, 2, 3, the first 3 questions are integration technique. So you can integrate using integration by part, which is a method for integrating anything that's multiplied. That's why we do U and V. U and V multiplied is where you use integration by part. Integration of trig function, how do we integrate sine, cosine, tangent, cotangent, secant, cosecant, how do you integrate sine squared, cosine squared, tangent squared, cosine squared, secant squared, cosecant squared. So most of the common integration of trig function, we should be able to know it up to degree 4. I mean, integration of sine cube, cosine cube, tangent cube, cotangent cube, and the integration of sine horsepower, cosine horsepower. Now we should be able to know that. Other than that, there's a multiplication of how to integrate sine cube, cosine squared dx. How to integrate tangent cube multiplied by secant x. Tangent cube of x is secant x integration, kind of like that. So any, I would say after calculus 2, any trig function integration that has power lower than 5 are kind of a common question in 6.3. Number 3 is integration using partial fraction decomposition. It focuses on how do we integrate division of polynomial. So if you have one polynomial divided by another polynomial, it's being called rational function. If the numerator have a degree lower than the denominator, that's called a proper fraction, the proper rational function. If the numerator has higher degree than the denominator, we have to divide it. We have to do a long division. Then you end up having a polynomial plus a rational function. The integration of partial rational function, we use partial fraction decomposition to make the big integration into several smaller integration. And that's 6.4. Question 5 is about volume calculation. There are 2 methods of volume calculation, the shell method and the disk or washer method. We learned that in 7.2.7.3. And so that's one of the skills that we did in chapter 7. And there's a calculation of surface area. 7.4 have 2 topics, surface area and length of the curve. I felt like we've done a lot of length of curve calculations. So on the final exam, I'm going to put a surface question there. Number 6, infinite sum. We learned how to calculate, how to find out the total summation if you add the infinite many number that has a pattern, that has a formula. So 8.3, 8.2. Taylor's series expansion is from 8.6, 8.7 and 8.8. The equation of tangent lines for the parametric equation is 9.3. Polar equation matching the polar curve is 9.4. So we actually cover way more than that in the sections, but I can only test so many. So I pick out a few questions that we didn't test as much in the previous exams and combine them into the final exam. Question 10 is length of a polar curve or area within a polar curve. So it could be length, it could be area. So I'm putting it there so you actually have to study the whole section rather than only study length or only study area. So that was a study guide. Any questions? On the study guide, I see we're going to have an example of this. So you can see I didn't post a study practice question on Georgia View. Actually put it under in web work. That way you get a study and actually post your answer in there. So when you log into web work, you're now going to see one more assignment. Again, the last assignment is called, I guess I should try to see what's on the student side. So let me try to. So it's really too simple. So last assignment is called final exam practice. And there are 13 questions. I originally put a 10 question there since we were supposed to work out 10 question on the final exam. But then I realized that some of them had multiple version of it, so I added a few questions. So, but the final exam will have only 10 questions. So you can work through this integration by part and trig integration. It doesn't have to be that one. That was just the example. Question 3, this is integration using partial fraction decomposing. You decompose the fraction and then you integrate. Next question is a volume calculation. That's the surface area calculation. That was an infinite sum. And then I feel like this one was a little particular. So that's why I add a few infinite sum questions. And that'll be the question 11, 12, and 13. Question 7 is Taylor series. Question 8 is equation of the tangent line for parametric question. That was a question on the exam. You probably remember that. And this is a question for the polar curve. So we have, those are the polar curve, the graphs, and those are equations. We match the equation with the graph. So this way we get to cover more semi-area along polar curves. And then question 10 is try to find area within that's like outside the inner curve and inside the bigger curve. So really is area between. That is the last question on the exam. So if you didn't do so well, then this question will be for you to practice. Next problem. So those are all infinite sum. Complete number of infinite sum. If you did it already, this will be like just practice. All right. So that was plan. Oh, thank you. That was a plan for the final exam. Any questions? So if there's no questions, I'll let you practice. And if you have a lot of issue with this question, we can talk about any concerns that you have on Monday. But today we're gonna work on more practice question. So you guys will be doing the calculation. So we just practiced one. That was another example of integration by part. And here we have an example of integration by part here. So by now we should have some experience working on integration by part. So you shouldn't be afraid of integration by part by the end of the calculus too. The second question I want to try is trig integration. Okay, so let's try this one. So on web work, I have an integration, trig integration. That was tangent to the fourth power, and this is the secant to the fourth power. These two are similar. Okay, I hope that we have a plan when you see a trig integration. Just imagine if you have to integrate sine to the fourth power. How do you do it? If you have to integrate cosine or sine cube or tangent cube, the kind of visualize would be the plan. If we are able, and most of the common question, if we have a plan, then we'll be able to handle them when they're on the exam. Let's try this. Scanner on. How much time it takes us to finish. So just basically, I'm making an example for the final exam, and we practice along the way. And we see how many questions we can finish in one session. And we were trying to do 10 questions today. But if we cannot finish 10 questions, we can practice more on Monday. To just select possible question for the final exam and start practicing. We'll wait to 30 seconds to finish this question. Let me see. Those are correct. Thank you. Too many times the question is more familiar with it, and then you may have an idea of how to do it. But the thing is, you gotta make sure that you can do it independently. And if you are at home or when you have your notes, your class notes, your homework notes, you probably can find out the answer pretty quickly because you might have done it already when you do your homework. But make sure you're able to do it without looking at anything. That means the idea, the method is with you instead of in advance. So far, all the answers are correct. You're holding part of the edge of the, okay, that's right, thank you. That's right, thank you. Okay. Thank you. So it's 2 minutes already. You can kind of plan for how much time it takes you to finish 10 question. We got 2 hours on the final exam. That means, in 1 hour, we have to finish 5 questions. So then every question takes 12 minutes max. So when you're solving each question, if you takes really, really long time, you probably think about switching to a different method that takes less time to we work on each question. I mean, it would be better if we can time ourselves. That's why there's a timer on the paper scanner. You can see on the screen in the middle of the screen. It's now 3 minutes. Okay, I'm guessing most of us has already done. Let me explain the answer. I know you may have a different approach. I mean, calculation of integral, it's not always the same method. Right, so this is equal to, I would say for secant, the secant square is the derivative tangent. So I know there's already a derivative. So we have 8 secant square of x times secant square of x dx. So one of the method is to make u equal to tangent. The derivative tangent is secant square. So in this case, du would equal to secant square of x. The tangent is secant square dx. So right there, we have this is du. Okay, so we are slowly, we were doing, I did substitution method. So we're replacing variable with function u. And then this part, we want to make sure to write it out in terms of u. So then you see, because of secant square of x actually equal to tangent square of x plus 1. That's a triggered identity. So that means that this is equal to u squared plus 1. Right. So what you observe there is this secant square actually equal to u squared plus 1. And then we still have the 8. And we still have the integration. So now the question become a u integration. So we switch the variable. So that's why it's called a substitution method. We substitute the variable. We change the variable from variable x. So in the original integration question is all about variable x. Now we have this rule, the integration that has variable u. So there's no more trig. After the substitution, we will integrate using power rule. So we have 8. You integrate u squared to u cubed over 3. We integrate 1 into a u, right? Then plus 6. So now we finish the integration. On the middle part is just explaining this the substitution process. So out there are the actual integration process, and down here we're just explaining the change of sign, change of notation. And it's better we put it back to the original variable. Since the variable is x, u equal to tangent cube. So the final answer is this is equal to 8 over 3. See, 8 over 3. 8 over 3 u cube, and u equal to tangent. So this is actually tangent cube of x plus 8 over 3. So there's no 3, which is 8 u but u is tangent of x. And of course, plus c. So it is, we change the variable back to x. So if initially we change the variable u because it will make the integration easy. Once we finish the integration, we write it back to the variable x. U equal to tangent x is how we substitute back and forth. Now we finally have the answer. You see the answer is supposed to be C. Okay, so we compare this one with this one. Final answer. So that's the whole process. I can see most of you already have the right answer. If you don't, I think you should be finding it now. The answer is C. So you can see the answer is C. Right, let me know if you have any questions. Still with me? Okay, I have to turn this on. I got 15 answers. Most of you get it right. Okay, so that's this question. Do you have any questions? So that will be example for the trig integration. That is what we were planning for the second question on final exam. After that, we should have a question of decomposition. This question. Right, so this is a question from 6.4. I was planning on to do this for question 3 on the final exam. Let's see. So you would rewrite a fraction. This is something we've done before. It was one of the quicker questions we practiced at the beginning of the semester. You used to have your notes, but if you don't have your notes, you can start rewriting it. Remember the fraction. You gotta have the numerator lower degree than the denominator, which we have. So there's no extra work, no extra division. Numerator is degree 1, denominator is degree 2. And you will see if the denominator can be factored. If the denominator cannot be factored, it will be irreducible. And then we have to do, I guess, integration by substitution. We have to separate this into 2 integration. But this one, the denominator can be factored. You can see 40 equals 5 times 8. And 8 minus 5 is 3. So we decompose the denominator. Let me turn on the scanner. If you already have the answer, feel free to. That's right. Thank you. Sometimes I wonder how did you get your answer so quickly, because I would be writing it down. It at least takes me 1 minute to figure out what's the answer. So you kind of see that you guys definitely have a quicker approach or quicker method. I wonder if I can. During class, I probably asked you to show me your work, but I'm curious. Because personally, I'm the kind of people that have to write everything out. So it always takes me longer time than other people to do anything. And you can see that when I was explaining anything in class, it takes longer time because I gotta write it out until I have any confidence. Sometimes I may think about the method, but I'm not confident or I'm not comfortable with my answer until I write every single detail out. That's the thing everybody learns. When I was in college, I was always envy my classmates. They were able to think in their head, but I'm not the kind of people that think in my head. I always think with my pen. That's why I ask everybody to write notes, because that's how I can think. That's right. Thank you. Now it's 2 minutes. They're very similar, so it's easy to. It's easy to make mistakes too. No, that's why I see they're very similar, so I don't watch out for small details. And that's right. Uh-huh. So you wanna check your steps, and then sometimes it's really small things. That's right. I'll try to go through the steps. This is closer to holding it now. The calculation, if we would rewrite the fraction. Okay. When you rewrite the function, it's this function. So we don't integrate immediately. We try to write into the summation of two small fractions. Notice the denominator actually equal to x minus 8 times x plus 5. Right, that way the minus 8x, there's a plus 5x, you multiply, and I give you the negative 3x. Negative 8 times 5 is negative 40. So if you multiply across the two parentheses, you see those negative 8x and positive 5x, that's 3x. And then these two multiply is negative 80, and these two multiply is 6x. See all of that in the decomposition. So we realize that this denominator is the same. It's a multiplication. So we were able to rewrite it decompose it into two fractions, x minus 8. And this, you need a number, an unknown number, and then x plus 5. That's the process that we call partial fraction decomposition. So we're decomposing a base fraction into summation of two smaller fractions, simply because it's easier to integrate. So integration of that one becomes integration of this one, plus integration of this one. So once we finish decomposing it, seems it's way more easier for integration, right? So let's go back to this. And then in order to make this exactly equal to each other, we multiply both side equation by the denominator. So multiply the left side with the denominator, you're gonna have 5x minus 1. And multiply the right side by the denominator, you're gonna have 8 times. The denominator will cancel, the x plus 5 will still be multiplied. Right, for the b, the denominators cancel, this you'll have to multiply x minus 8. So that's what would happen if you multiply both side equation with the denominator. So then a equation that has the denominator, now we don't have any denominator. That's we now can focus on isolating the a and b. So this equation, all right, has x. It also has a and b, and it's actually a function equal to another function. So on the left side, we have function 5x minus 1. On the right side, we have a times the function plus b times function. They were supposed to be good or correct for any x value. So the method from now on, there's two approach. In the book, we are looking at coefficients. For example, the x has coefficient 5, but on the right side, it has coefficient a and then b. So a plus b is supposed to equal 5, right? That's the equation. And on the right side, we have -1. On the left side, we have -1. On the right side, we have 5a plus -8b. So that means those are supposed to equal to -1. So you can set an equation, a plus b equal to 5, 5a minus 8b equal to -1, and you solve a and b. So using solving the system equation, you can solve the answer. But I prefer the other approach because I really don't want a longer equation. So we would choose a special number for x. You can choose special value for x because this equation is supposed to be correct or equal for any x value. So I'll put x equal to -5 because when x equal to -5, the left side equal to the right side always. So if you make x equal to -5, the left side will equal to 5 times -5, which is -20, -1, which is -26 on the left side of the equation. On the right side equation, when x equal to -5, x plus 5 equal to 0. So this is 8 times 0 plus b times -5 minus 8. So this will be 0. That one is b times -5 minus 8. All right, so this is actually b times -26 equal to b times -13. Divide -13, b equal to 2. So we realize that now we have a number, this numerature. At first, we don't know what it is. Now we know. Now we know this is 2. So we find out the actual decomposition coefficient. All right, and we also have to find we now find b. We also have to find a. So another one would be, let's choose another number because we still have to solve the a. So we choose again two special values. So this equation, just remember this equation is a function equal to another function. Function has variable. So we choose the easier number for x. Let's choose x equal to 8. So if x equal to 8, then the right side is 5 times 8 minus 1, you get 39. The left side, x minus 8, that was 0. So b times 0 is 0. And on this side is 8 plus 5, and we have 13. 8 times 13 is 13a. Okay, with this, we can see that a equal to 3. And that means the numerature here, first, we assumed it was a and b, and then we went ahead and tried to solve it. It turns out it was 3. So now we have the decomposition. So as we planned before, if you're integrating this equation, you have to integrate this plus integrate this. Now, this integration is, for this one, you bring the 3 outside, 3 integration of 1 over x minus 8. The antiderivative is natural log x minus 8. Because natural log x minus 8 is derivatives 1 over x minus 8. Natural log's derivative is 1 over the inside portion. And then the second one is plus 2. And then natural log of x plus 5. But this finished the integration and everything is done. You can see if you are writing a paper, what you're writing is just the top row of calculation. People may not want to know the calculation. And how do you find out the a and b? How do you know this equal 3 over this plus 2 over this? That's the decomposition part is when you are looking at the detail of the calculation. But anyway, I'm trying to explain the process. In this course, we're supposed to write everything down so it's clear of how the process down. But with a research paper or something that you report your answer, you might not have, you don't have to write so many details. But I think it's beneficial to know how things work out. And then behind the scenes, to find the a and b, there's multiple methods, but it depends on the equation. For this one, they're all degree one, x plus a degree one, x plus 5 degree one, they're all degree one, so it's easier choosing special value. But when you have higher degree or like irreducible term, and then matching the power line. You see some example when we're doing the homework, but this one, because the denominator can be factored, it's way too special. Okay, you have done putting in your answer. Anyone that's still in the process. What else? Do you have any questions? Any questions? Okay, we'll start the scanner. Let's move on to that example. Let me see how far we are as far as the study guide who's trying to work through each example. Oh, different browsers. Okay, so we're up to 1, 2, 3. Probably. All right, let's move on. It's the next question I want to try is a volume calculation. Try this one. That's right. Thank you. Yeah, thank you. I wish everyone was in class and I was like, show me your work. But that's the thing, it's very hard to be able to see everybody's work. Even if we're all in the class. I would go by start by graphing the picture of the region that we're revolving. So we got solid result by, so the curve that we have, and here we have y equal e to the x. Then we have y equal to 0. Y equal to 0 is really the x-axis, y equal to 0. Right, and then x equal to 1. And then x equal to 2. 3, exact. X equal to 2. So the region is bounded by these 4 curves. Okay, so that's the shaded region. We're revolving this about x-axis. So you just imagine the revolution is, this is revolution. This thing is being revolved this way. So it's revolving about x-axis. So when you have a rotation or revolving about x-axis, the radius is a y value. R equal to y. And just imagine you're revolving this way. So that's your y, right? That's your radius. This is the center. The radius, the center, this is the radius. So either way, up or down, it's the y value. That's the revolution. Radius equal to the y value, or another way to say it's the absolute value of the y value. But in the shaded region, the y are all positive. So we don't have to absolute value of the y. All right, so now we have our y value. Let's think about the volume calculation. If we were doing, so this is the part we're revolving there's no hole in the whole thing. It's ends up being some kind of solid. So we will do integration of pi r square. Pi r square dh. If you are using the disk method, if we're doing the shell method, then is 2 pi r d, 2 pi r times it's a shell, right? 2 pi r times h and dr. So the shell method, the integration variable is r, but the washer method, the integration variable is h. I'm just going. Let me see your answer. Correct, thank you. Many of you already have the answer. We want to go through the calculation part. So let's see, we already know they are equal to y, so this is going to be the y squared, but then and the h supposed to perpendicular to the r. So if r equal to the y, then obviously the h will be the x. So we're gonna do dx. So we have the dh become the x, and r supposed to be the y. And what would be the y? Why is this? This is 0, and this is e to the x minus 0. This is the y. So r equal to the y, and y equal to e to the x. Right, so then the r squared become e to the x squared, or e to the 2x. That's the r squared part. Okay, and we would do pi e to the 2x, and we integrate from integration variable is x. X is from 1 to 2, so it's 1 to 2 pi times e to the 2x dx. So the integration, pi is coefficient, and the derivative of e to the 2x is e to the 2x divided by 2. It's the chain rule. And we put in the upper limit and lower limit, which is 1 and 2. So the calculation will be pi over 2 to the side, e to the 2x. When x equal to 2 is e to the 4, minus when x equal to 1 is e to the 2. So that will be the whole calculation. Okay, so that's the whole process. I hope that kind of explains. This is a disk method. I probably don't want to do the shell method, but if you want to, you can try. If we are doing, let me just explain. I think this one can be either way. You can also calculate with pi equal to integration of 2 pi r h, which is a shell, the area, the area of the shell, and the thickness of the shell is the r, right? In this case, the integration variable is going to be the r. Remember r equal to the y, so it's going to be ey, so it's 2 pi e to the x. It's the y variable, right? It's 2 pi y h equal to the x. So y equal to e to the x by 2 pi y h dr, and r equal to the y, so it's dy. That's why I need to find out the h. What was the h is over here? It's h. This is an r. So h will be 1 minus this, 1 minus the x value in here. So you have to solve the x value from here. The x is equal to natural log of y, right? And then the h will be a subtraction of those x values. And then this is shell. This is the height of the shell. So h equal to 1 minus, actually it was 2 minus. It's 2 minus natural log of y. That's what the h is. That's what's making it kind of a long process for the calculation. So 2 pi integration y times 2 minus natural log y dy. And this will be how you would calculate it with the shell method. Definitely not a preferred method. The calculation will have to do the y, the 2y will be integrated into y squared, but the y times the natural log of y, we have to integrate using the integration method part. So it's possible to do it with shell method, but it's definitely easier with the distance as far as this one goes. And that was this example. The solution should be A, and most of you have already submitted. I see 13 answer. Okay, thank you. Okay, and then 16 for wrong answer. So everybody already saw the process. Eugenio, the answer is A. I think you did B. It was this one. The calculation process is here, and that's why the final answer should be that. Should be A. We didn't get carried away by another approach, but it was not very easy to do it. It takes longer time. We also have to find the integration limit for the y value, so probably don't want to do the shell method instead. All right, I don't know if that was the example for the volume calculation. You can also try the one that we see in our in the practice question sets. This the volume calculation. The next question should be a surface area calculation. Let's try this one. The reason. Okay, let's work out a surface area calculation. Try this one. So we're revolving the curve y equals x plus 1 from 0 to 3 about rotating about x-axis. So the curve is a one-dimensional thing, a line basically. And if you revolve it, you're forming a three-dimensional surface. And we could even write an equation of the surface if it's revolving about, I mean, like if you put it in the three-dimensional equation of surface about the x-axis will be y squared plus z squared. Right, in that two. So then the radius will be in the two-dimensional, will be the y map. So it will be y squared plus z squared equal to x plus 1. But we're not running the equation, we're calculating the surface area. So surface area, and let's review the formula, which will be integration of 2 pi r pi dl. I mean, the dl is going to be square root of 1 plus derivative square times dx. And let's see. That's right. Thank you. Okay. Right. Add a little bit more assistance to it. The formula for surface area is from section 7.5. It's integration of 2 pi r dl, which is 1 plus.
Hi.
Yes. Okay. Is there anything else? Dx. Anyway, this question was revolving about y-axis, revolving about x-axis. So the r, the radius, actually equal to the y. I mean, because the x-axis have an equation, x-axis equation y equal to 0. So when you try to find the radius, at the center of the circle, the y equal to 0, but at the edge, the y equal to y, so the radius will be y minus 0. So it'll be y. So I just want to explain the equation of the radius by the center of the revolution. So x-axis represented by y equal to 0, and therefore there's the y. So radius equal to y, and what was the y? Y equal to this. Okay, so that y goes in here. That's what it looks like. So you're supposed to calculate it like this. So we have 2 pi root of x plus one, always the r, right? And then multiply by root of one plus, here you're gonna need a derivative, right? That was a function. The function f of x is equal to root of x plus one. So then the derivative is equal to 1 over 2 square roots. Power rule, right? The power is 1/2. So you take the power to the front, the power 1/2 minus 1 is negative 1/2. Negative 1/2 is 1 over square root of x. That was the process. So this just goes in, you have to square the derivative. So the derivative is this one, you square it, it becomes 1 over 4 x plus 1. I mean, 2 squares 4. So that's the actual process from the formula to the actual calculation. The integration limit should be the x value, and you can see the x value is from 0 to 3. If we work it out, it would be, see what it is. And, and halfway finished. Integration limit is given by this 0 to 3. This is x variable x is 0 to 3. Okay, you're gonna finish the summation there. See what it is. No. It was almost there, right? This is actually 1 plus 1 over the 4 multiplied is 4x plus 4. So if you want to add it, it's actually 4x plus 4 over 4x plus 4 equal to 1. So this is plus 1 over 4x plus 4. I was just working on the inside of the reach, which is equal to 4x plus 5. This is the 4x plus 4. So that's what's going there. Okay, yep, can you get this? What? Yeah, she asked, you asked, she wants to say something to you. Earbuds at your foot. But, oh. I'm sorry. Okay, anyway, I think I got everybody's answer. So the final answer is B. As you can see, I'm trying to get that part. Let me try to explain the rest of the calculation steps. This calculation is actually possible to finish up. And that was the explanation for the function and the derivative. I removed that part. And let me remove that part as well. So then the actual calculation is actually integration 0 to 3, 2 pi square root of x plus 1. This is square root of 4x plus 5 over 4x plus 4 dx. Okay, which is why we see the answer is B. Now this integration can be finished. The question just did not ask for calculating the final calculation, but we should be able to finish it as what we did in the section. So the calculation will be the denominator. Copy this so we can work on. Okay, so we see. So what will happen is this, the denominator, this part of the denominator. can be simplified. You can bring a 4 out of it. The root of, well, it was originally 4 times x plus 1 there. So we can move it into a root of 4x plus 5 divided by root of 4x plus 1, 4 times x plus 1. So with that, the 4 can get out. So this 4, we can get out of the root and become a division of 2. I mean, the root of 4 is 2, and that would remove this 4 there. And that was the root, then it becomes root of x plus 1. Root of x plus 1 will cancel the root of x plus 1. So the integration becomes the integration of pi, right? And then the 2 over 2 is 1, so that cancels as well. So it's become pi times root of 4x plus 5 dx, and then x is 0 to 3. Now this is not too hard to integrate because there's nothing outside the root. It is degree 1 inside the root, so that's really pi times 4x plus 5 to the power 1/2. We can integrate this with power law. So integration of this with power law. We then have, just want to finish the calculation, pi times the power is plus 1, so 4x plus 5 to the power of 3/2 divided by 3/2. Right, so this is the power rule for integration, but then we have 4x plus 5, and 4x plus 5 have a derivative 4, and this is integration, so we don't multiply by 4, we divide by 4. There's a derivation of 4. That's the whole antiderivative. We're going to plug in the integration limit. There were 0 and 3, so the calculation would be in the denominator, the 2 and 4 cancels. 3/2 times 4 in the denominator. So denominator is actually times 2. Or in another way, we say it's pi over 6. Pi over 6 times, if x equals 3, it would be 4 times 3 is 12. 12 plus 1 is 17. So 17 to the 3/2 power at upper limit. And the lower limit is when x equals 0. So that would be 5 to the 3/2 power. So that's the antiderivative. And that's actually the calculation of the definite integral, which gave us surface area. So then this will finish up the whole calculation. But I'm just saying this question is possible to finish up the calculation and know the surface area instead of just figure out the equation of the surface area. Let's see this example. I mean, on the actual final exam, you definitely need to know what was the surface area rather than just the calculation of it. And that's why I'm trying to finish this up. The answer should be B. All right, we got 10 minutes more. Let me try one more question. Another question. After there's volume, there's surface area, infinite sum. So sum should down to the right. I'm seeing chapter A, we did quite a few calculations of the infinite sum. Let's try this one. This will be the last example for today. Let's find this summation. I don't know if you still remember it, but it involved the partial fraction decomposition. So you decompose that fraction into a subtraction, and then this infinite sum will be a telescoping theory, which means that partial sum can be combined. So the infinite summation can be calculated by canceling any of the middle term. When the middle term cancels, you can see the initial term left after a couple terms canceled. So we can find out the answer from the beginning using the first term and the last term in the partial sum. It's out of this thing uses up a lot of power. You know, they don't get to here. To make loud sound. Okay, one last question. Ask me to share. Turn on the scanner. Let's try.
That was 5 seconds. Sorry.
I feel like maybe for some of us, it's not the first. It's not the first time we have done these questions. So, I mean, just imagine you're thinking.
That's a very optimistic way of looking at it, and they just put it into Gemini or ChatGPT.
Okay, but you still have to be able to understand the question. Okay, many of us already have the answer. But I see quite a few of the answers are not right. I mean, all the answers submitted half right, half wrong. So I'm like, what's going on? Let me try to explain this one. I use this one as a bonus question one day, so I kind of understand it's not an easy question. So let's see. You might want to write out the first few terms to know how does it look like. Which we might have to think about the division and subtraction, write it into a subtraction. So what we're gonna do is we rewrite this in 2 over, you see the denominator has n, we factor out the n times n plus 2, that's the denominator. So using the decomposition process, this is supposed to be equal to a over n minus b over n plus 2. I'm doing partial fraction completion here. So that would be, we multiply both sides of the equation with the denominator. We will have 2 equal to a times n plus 2 minus b times n. When n equal to 0, and let n equal to 0, we have 2 equal to a times 2. That means a gotta be 1, right? And then when n equal to -2, which just shouldn't be because n was natural number, but for the sake of solving this equation, and when n equal to -2, we have 2 equal to b, -b times -2. Is that even right? That's right. So b equal to 1. Are we okay? Right, are we okay? So then we were able to rewrite it, a equal to 1, b equal to 1. So this whole summation is now equal to summation of 1 over n over 1 over n plus 2. So you were able to write the whole infinite sum into this. Okay, it's now time to write it out. So when n equal to 1, it would be 1 minus 1 over 3. When n equal to 2, equal to 1 over 2 minus 1 over 4. When n equal to 3 is 1 over 3 minus 1 over 5. When n equal to 4, 1 over 4 minus 1 over 6. I mean, the more you write it, the more you can see the pattern. Right, many of the terms are all going to cancel. I mean, this being able to write it into a subtraction is really useful because you were able to cancel the positive term with negative terms. You see, this cancel this, they're opposite, and then right, and this will cancel this, and that one will cancel this one. Right, and the pattern can go down. You can see there's definitely going to be 1 over 6 and 1 over 7 later, right? It's always a positive term minus negative term. These should be able to cancel in the end, right? Right, as we keep going, because the summation is an infinite sum. It doesn't stop here. So see, this is the 5th term, the 4th term, the 3rd term. So after that is a 6th term, we got 1 over 6 minus 1 over 8. So that one was canceled. right? And if you keep doing it, this following term will also be canceled. So you can see that's canceled, that's canceled. So what do we have left? Right? So it's 1 plus 1/2. So the final answer should be 1 or 1 plus 1/2, because any other term are canceled following the future terms. And if in the descending order, the number, if you try to expect anything after this, after 6 or 7, those are getting smaller and smaller, right? So the limit of those number is 0. So you can see the first two, actually, the second number was canceled too. The only number remaining is 1 plus 1/2. So summation. And the better approach is write the partial sum. But I didn't wait for that. If you wanna, follow our method is n equal to 1 minus 1/3 plus 1/2 plus 1/4, and then plus dots, and then plus 1/n minus 1/n plus 2. That's what we mean by S sub n. And then we see some cancellation, cancel this. All right, the only one that was also canceled was left is 1/, it's negative 1/n plus. 10 plus 1, I think. That one, and these two are left. When n goes to infinity, we don't have the 0 limit, so the limit of Sn is 3/2. So the final answer should be 3/2. Let's finish today's example. Next Monday, we'll practice a few more. But if you are okay with it, go online to the webwork and practice with a final exam practice question. If you're confident, I'm not trying to get everybody to be attending on Monday, but this one, definitely try it. So if you understand everything, if you feel like you will be beneficial with more practice questions, then that's what we're gonna do next Monday. So next Monday, bring your question and, any concern or problems, and then you'll be coming for more practice question. But if you feel like all good and you feel like you're pretty confident about it, it's okay if you want to skip Monday class. Any other questions? I hope that everybody will be successful. So if you are not planning on coming on Monday, this will be the last actual class session, but I'll be around. I have office hour most of the morning time from 9:30 to probably 1 o'clock. But you can also meet me at other times. And we have exam May 6th. I have 2 exams in May 6th morning. So we don't have office hours May 6th exam day. But any time before the exam day, I'll be available on campus every day in the morning till 1 p.m. And then again, feel free to send me a message if you have any other question or concern. I may or may be able to see you on Monday, but you're welcome to stop by with any questions. Right, email me or come to see me at the Math Lab. Right. Best of luck. Right, see you on Monday. Monday is May 4th, and May 6th is Wednesday.
Monday's the last day of class.
Monday is the last day of class, yeah. Normally, we have regular classes on Monday, but because there's only one day, and also we're really busy last week, so I'm not sure everybody will be able to attend, that's why.
Is the exam at like 11?
The exam is. Actually, I posted it on, but then miss that, final exam is May 6th and 13 people in the same class.
You guys have a note card like this?
Yes, a page, your paper, like one, like a page. Yeah,
full
like one
page?
page on you. The final exam is longer and cover the whole semester, so you're allowed to bring one page.
Okay.